Okay, so now that we know the types of mass movement, why do these things happen? So let's think about why mass movements actually occur. So what happens is your surface is somehow weakened or loosened. So we call that slope failure, when a surface is actually loosened or weakened from the bedrock, from attaching to the earth. Slope failure is allowed in terms of the physics. So it depends on the materials involved and also how stable your slope is. So how stable is your slope being how steep is it? So this slope is going to be more stable than this very, very steep slope. So there are a couple of forces. The force pulling down slope. There's the resisting force, which is often friction, and then we have gravity as well. So there's different forces that go into play. We are not going to get into the geometry, the physics, or anything of this, but we'll just talk about the concepts. So the downslope forces, forcing your object or your regolith, your rock, downhill, mainly gravity. So how heavy is your object? Is there water? Are there already structures like joints? And then also we have the opposite, which are resisting forces. So resisting forces are how strong is your material. So how cohesive is it? How strong are those chemical bonds? How strong is the friction? And by that I mean cohesion is how easily do the particles stick together. So how stuck together are the different particles, or how easy is it for the particles to separate? So if you have strong cohesion, that means that it's very, very stuck together. It's going to be difficult to separate that object. Bonds being how strong are the chemical bonds within your rock, and friction. So how much friction is not necessarily between the two layers, but also between the grains. So how much friction is actually between the grains in your sediment. If you have high friction, that means your grains are not going to move against each other. They're not going to slide away from each other. If there's low friction, that means it's going to be much easier to slide. So adding water is going to decrease your friction. So adding water, say, to some sediment is going to make your sediment much easier to slide down a hill. So the strength, or the strength of your resisting forces, the strength of your material, is really the cohesion plus the friction. So if you have strong cohesion, so your particles stick together very well, and you have a lot of friction, which means there's no water, which means it's very hard for the grains to slide against each other, you're going to have a very strong material. If you have low cohesion, which means they separate easily, and low friction, which means they slide easily, you're going to have a very, very weak material, much more likely to have a mass movement with a weak material, especially if your slope is steeper. So when we think about slopes, we think about the angle of repose. So the steepest slope possible for that sediment to remain stable is going to be the angle of repose. So if your slope is any steeper than your angle of repose, it's not going to remain stable, and you're going to have some sort of slope failure. You're going to have a mass movement if it gets too steep. So if you think about a pile of sand at the beach, as you're making a pile of sand, there's really only a specific angle that you can make that pile of sand before the sand starts flowing down. So you can't build your sand up to a super, super, super steep, say, like skyscraper shape, unless you have water involved, because the angle of repose for your sand is only about 30 degrees. So the angle for a stable slope depends on the material. So really fine-grained material is going to have a lower angle because it's going to slide easier, so it can't get as steep and still remain stable. Whereas something like angular pebbles, like this pile here, you can actually pile up at a steeper slope because they aren't going to falter as easily. It's not going to have a failure or a mass movement as easily because these are really irregular, they're larger, they're a little more locked together, say, than the fine-grained sand, which can flow quite easily down this slope. So that is the angle of repose. So when we talk about mass movements, we talk about the angle. So is the slope stable? And then we also talk about the strength of the material. So when we see failures, failures meaning a failure in the rock, in the surface, we mean a mass movement. And if it's one specific mass movement, we usually call it an event, so a mass movement or a mass wasting event. We often see, well actually we always see that it happens already along some sort of surface. So here is an example where we have a mass movement. This block slides down along this already jointed surface. So here we already have a joint parallel to the surface. Here there's more jointing allowing for this rock to slide down. Here we have a block sliding along a different bed layer. So some of the bedding themselves, different types of rock against each other, can allow for a mass movement. So this bed of shale, for example, acted as the failure surface, allowing this block to slide. And then this can also happen with foliation. So you know this is foliated, so it's metamorphic rock. We can have a block slide along the layers, along the parallel foliation lines. So where we have some sort of linear feature in that foliation, we're going to have an easier time breaking the rock, sliding the rock. So that rock will actually slide along that foliation line, along that linear foliation line. Okay, so we know how the rock falls, but why does it start to begin with? So there needs to be some material that is relatively weak, so it's not too strong. We also need some sort of angle to allow this rock to fall. And then we need a starter. So we need something that starts this mass movement. So it can be a shock or a vibration, something that causes the mass, which is already ready to move because of the angle and the strength. We need something to actually start the motion. So the most common are a change of slope. So if something about the slope changes, all of a sudden the slope gets steeper, or something on the slope gets heavier, that's going to cause the mass movement. So water, often if there's a lot of water added to the top, that's going to get very, very heavy. That's going to allow the material to slide downhill. Construction often does this. So if we're moving the material, if we're digging out material in one place, adding it to another place, we might be loosening or lowering the strength of the material by pulling it apart, and then also piling it on another area, making it heavier, allowing that slope to actually fall. We can also have a shock, sort of like an earthquake. So if there's any sort of earthquake, that can cause a lot of mass movement. That little bit of vibration might be exactly what the slope needs to fall. Construction, again, if we have jackhammering and digging and drilling, that can cause the vibrations that causes some sort of mass movement. We also have what we call undercutting. So if we are along the ocean, this is very, very common. Our ocean waves are going to erode away the rock that the waves can reach. So this rock is above wave height, so this is some sort of cliff right along the beach. The waves are going to erode this rock underneath. Eventually it's going to become over-steepened, which means there's an overhang. This overhang has nothing to support it. It will eventually fall. So that is generally where we see a rock fall above or at a body of water. This is what's happening. So changing the slope strength, we might have weathering. So weathering can weaken the rock. It can cause joints and fractures and cracking in the rock, making that rock itself weaker. Also vegetation cover. So if we have if we have vegetation growing, that usually causes the slope to be much more sturdy, so much stronger. So the roots will actually help hold the slope in place, as well as they remove water. So they remove the water that changes the friction. So water content, so a small amount of water will actually help keep the regolith together. So if you picture at the beach, again, you cannot make a sandcastle with dry sand, but you can make a steeper, taller sandcastle with wet sand. So if there's a little bit of water involved, it's going to help stick the sediment together. But if you have too much water, the water pressure will push all the grains apart and you'll end up with liquefied sediment. So you'll end up with mud. So a little bit of water is good for the strength of your slope. Too much water is too much water. It's also really important to think about the climate. So if we have a very, very rainy area, we're going to have a lot more water-based issues. We're going to have increased weathering. You're going to often have too much water where things will flow as mud. And then also think about the relief of the area or the topography of the area. So are there steep hills? Are there steep cliffs? If you're in an area that has really steep cliffs, really steep hills, your likelihood of mass movement is going to be much higher. Whereas if you live in a very flat area, you're not going to see as much mass movement. So when we think about the risk of mass movement, if any of you are in the home buying phase of your life, you might want to think about the risk of mass movement. Generally, you just want to look for as evidence of past events. So have there been mass movement events here before? That means there probably will be again. That means there's water. That means there's a steep enough slope. That means there's already joints. There's already fractures in our rock that have caused mass movements recently or in the past. It's going to happen again because the climate of your area is relatively similar, unless there's been some sort of engineering, like human-made engineering done to prevent further mass movement. You can expect it to happen again. So here, for example, here is some slumping. So we see that there's slumping at this little farm along this road. You'll be able to see these headscarp scars from past slumping events. You can also see the trees here have died because there hasn't been enough water there. So generally everywhere will have landslide or mass wasting potential maps, so you can actually look up your potential for a mass wasting event in your area. You can actually look the same way we do for earthquake potential or earthquake hazard. You can look up landslide potential, and they mean landslide potential as in all types of mass wasting events. So you can actually see the potential or the hazard for your area. So what are some ways to prevent mass movement? So I just mentioned there's some engineering that can be done to actually prevent mass movements. One of the things is revegetation. So like I said, you can plant more trees, add more root systems to your area. That's going to strengthen your slope. You can also regrade your slope. So if you have something that is a slope that's too steep, you can regrade it or recreate the slope so that it's not steeper than that angle of repose. Actually make the slope more gradual so that there's less potential for mass wasting. If the slope is unstable, you can make it stable. You can also remove subsurface water. So remove the water that's weakening the slope in the first place. So better drainage, moving the water somewhere else, not allowing for so much flooding in that area will remove the weakening of that slope. You can also prevent that undercutting like we talked about for the rock slides by building a breakwater, building something to block the water. You can also divert your river. You cannot do this with an ocean, mind you, but you can divert a river, change the river flowing. And then you can also just build safety structures. So like these down here, if you've ever driven on a road and driven by one of these, this is to block this land. So this slope here is too steep, we can assume, because they had to build this. So they actually built a wall to change the angle of repose. So now this land will not be able to slide into the road. Here again, you're adding additional safety structures to the top of this cliff right on top, so anything that falls either stays or it's not going to experience as much erosion, as much weathering, because the water is more contained flowing down the surface. So these are actually really, really effective when you have a rock wall, so where you have more of a cliff. You might see this fencing that's actually holding everything in place, not allowing for as much of the boulders to slide, as much of the pieces of rocks to slide into the road. Where you see these walls, it's generally holding back sediment, not as much rock. And then the last thing is controlled blasting. So this is something that's done a lot of times for avalanches. So the ski patrol at Mammoth or at Big Bear might go up and actually cause an avalanche because they know where the avalanches are occurring. So they're going to cause an avalanche in a safe way, so there's no people involved, get that hazardous snow out of the way, and make sure that the avalanche occurs, because it will anyway naturally, but make sure it occurs in a way that causes no harm. So there are a couple of ways that we can prevent or at least reduce the danger of mass movements because we know already where they occur. So for your lab today, of course it's on Canvas. You will need a calculator, I believe, for some of the questions. I enabled the Canvas calculator if you want to use that one. And you will be using Google Earth for the second part of the lab. So it's free. This is the first time that we're using Google Earth. Here's the link right here. It's free to download. You can use it, you can use it on your phone or a computer. You can download the app to your computer, which is what I prefer, or you can use the website-based version. But it's really fun. I'm going to show you just one second. So this is what it looks like, Google Earth. In the lab, I think there's a couple different places that you're going to have to search. So you're going to search up in this box here. I typed Saddleback College Mission Viejo and I hit search, and here we are at Saddleback College. So what you can do, and what you're going to have to do today in lab, is you'll notice that as I move my mouse around, down at the bottom here we have the latitude and the longitude. So if I were to ask what is the latitude and longitude, here I'm going to zoom in, of the pitcher's mound here, you could put your mouse here, and then you read the latitude and longitude down at the bottom. So you can read it exactly where your mouse is. The other thing you can do is you can actually look back in time. So you'll notice this button down here is a year, and it says click to see historical imagery from 1994. So we click on that. You're going to have to do this in your lab. And we can actually see, here is our campus in 1994. So this is what our campus looked like. So our building, you'll notice, is gone. And then you can move through time. So you can move up. Here's 2004. Looks pretty good. It's funny that our baseball stadium has been in the same place. Historical baseball stadium. You can actually move forward in time. You can click on any one of these photos on our timeline, or you can just move forward using the arrows. So if we go forward, 2009, 2010, 11, 13, 2014, they were demolishing the parking lot to build our building. And then 2015, it's being built. 2016, there we are. Oh, I miss our building. But here we go. And here's where I park. And then here's our classroom right here. So you can move back and forth through time using this timeline up at the top. You're going to have to do that in class. You can move around. It depends on if you're using a mouse or a trackpad on a laptop. But you can zoom in, zoom out. It's the same as Google Maps if you've used that. And you can change your orientation. So the time, again, if you're looking back in time, you'll click the year down in the bottom left corner. If you're looking for the coordinates, it's constantly changing down at the bottom here. So when I ask you to search or go to whichever place, you're going to put that in the search window here and hit search, and it'll bring you right into that location. So if there are any questions on Google Earth, it's very, very well documented online. Also, please feel free to post in the discussion section, of course, the discussion board, of course, or shoot me an email. And have fun. It's pretty cool to explore the mass movements that have occurred on Earth using Google Earth. This is something we actually wouldn't have done in class, so I'm really excited about it. You get to see some real evidence of the slumps and the landslides and the toe and the head and the scars that are left behind. It's pretty cool.